Hello YouTube, Luigi here. Tonight we're going to talk about Pythagoras and stealing second base. Yes, baseball. Wow, how could there possibly be a relationship between Pythagoras and second base? Well, we're going to learn. Most people know the Pythagorean theorem as a squared plus b squared equals c squared. And this relates to the sides of a right triangle. Now, there's a right triangle. Everybody in carpentry knows this. It's called the 3, 4, 5 triangle. 3, 4, 5. This is a right angle. In geometry, you put a little square in the corner. It says this is 90 degrees. 90 degrees. Right triangle. 3, 4, 5. What does this mean? Let's say 3 is A, 4 is B, and 5 is C. We're going to take A squared. We're going to take the 3 and square it. So we know this is 3. If I square 3, I get, guess what? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 squared equals 9. Same over here. We're going to take the 4 and square it. 1, 2, 3, 4. 1, 2, 3, 4. Guess what? If you count the squares, you get 16. 4 squared equals 16. And then we come to this side. A squared plus b squared equals c squared. If we square 5, you know the answer to this already. We're leading up to second base, don't worry. 5 squared equals 25. So, if you're working backwards, let's say you know this is 3 feet, you know this is 4 feet, you want to know the length of the hypotenuse, well, you would take the square root of 25, which is 5. But we knew that because we started with a 3, 4, 5 triangle. That's sort of cheating. We knew what the triangle was when we started. That's a quick introduction to what's called the Pythagorean. Let me see if I can spell this right. Pythagoras. Pythagoras was the mathematician, Greek, ancient. Pythagorean theorem is a squared plus b squared equals c squared. Now, how does this get us to second base? Remember, it helps us determine the length of the hypotenuse of a right triangle. That's really what this is about. So let's say I have a square. Looks like a square, doesn't it? But you know, if I do this, and turn it this way, suddenly that square is a baseball diamond. Right? Right. The catcher is here. There's a runner on first base. He's trying to steal second. If we turn the diamond into a right triangle, see, 90 degrees, what is the distance from home plate to second base that the catcher, that long throw the catcher has to make before the stealer gets to the bag? What is this distance? Well, we know this is 90 feet. We know this is 90 feet, but we don't know this one, but we can use Pythagoras to determine this, can't we? I'm just going to punch up my calculator here. Okay, so how do we go about doing this? Well, we could say 90 squared, which is a huge number, plus 90 squared, which is a huge number, equals this distance squared. That's one way of doing it. But because this is a square, all squares are what they call similar. Just as all circles, regardless of diameter, are similar. What does this mean when I say all squares are similar? It means the ratio of this side to this side in this square is the same as the ratio of this side to this side in this square to this side to this side in this square, or this side to this side in any square. So rather than deal with huge numbers like 90, let's deal with a square that's 1 by 1. And we're trying to find this. And I'll show you how this shortcut gets us from 1 foot to 90 feet. Now, if it's 1 by 1, 1 squared is 1, plus 1 squared is 1. 1 plus 1 is 2. Right? Right. So this, remember, if we were working backwards, we got the 25, and we wanted to know the length, we took the square root of 25 and got 5. Here we have the total of 2, but that doesn't give us this because we need the square root of 2. Did you follow that? We know a squared plus b squared equals 2, but that doesn't give us the hypotenuse. We need the square root of that sum to get the length of the hypotenuse. So the square root of 1 plus 1 is the square root of 2. That equals 1.41. And because all squares are similar, you can take this 1.41, the square root of 2, and apply it to any side of a square, because all sides are equal, any side to get the hypotenuse. So 90 times 1.41 equals 126, excuse me, 0.9 feet. And this one factor, 1.41, works on any square no matter what the size is. Why? Because all squares are similar. That's it. That's how Pythagoras throws out the stealer, by throwing it 126.9 feet from corner to corner on the baseball diamond. There you have it. Ancient Greeks mathematicians weigh in on baseball. All right, stay curious. I'm going to say it again. Develop a thirst for knowledge. Life's full of great surprises, you know. Okay, hope you enjoyed this one. It was a quickie. God bless you. I love you all. Bye.